I'm Michael Phillips. I'm a research scientist and I manage the Space Imagery Center at the University of Arizona. At the University of Arizona, I mostly work on planetary science, focusing on Mars, and questions related to how the first crust on Mars formed and how that relates to habitable environments over 4 billion years ago on Mars. And so it kind of delves into astrobiology and habitable environments on that ancient side. But then I also have a different side of my work where I do a lot of modeling involving sort of complexity and neural networks. And we're basically trying to figure out how do you determine from orbit, where you have really low spatial resolution, at best something like 25 centimeters across with the HiRISE instrument, how from that distance can you tell where microbes might be living or might have lived in the past? Microbes are really small, they typically live in these communities, and they occupy environmental niches that can be really small, especially in places that are hard to live, like Mars probably was and definitely still is today. So there's this problem of spatial scale integration. How do you find something that's really small using orbital scale data sets? This analogy might make sense once I come around to it, but I played sports in high school, and when you play people who are better than you, you kind of play up to the level of your competition. And I find that it's also true when you're in an academic environment. When you're around people who are really good at what they do, you kind of elevate your own game. So I wanted to be in that sort of environment where people are doing really good work and advancing the field. So that was definitely a big attractor for me to come to U of A. And it's hard to find a place like that where the people are also nice. And U of A has great people, and I get along with them really well. So both of those things combined was an easy choice. Astrobiology is the study of life in our universe, broadly speaking. Now, don't dig too much into the details of life or our universe, because then you're gonna get different answers from different folks. But astrobiology you can bring your strengths to this field and make progress. And that's one thing I really love about astrobiology, is no matter what you're interested in, whether it's chemistry, whether it's fundamental physics, whether it's astronomy, whether it's geology and how rocks interact with their environment, all of those things those represent frontiers in this field of understanding how life evolved here on Earth and where life might be, either within our solar system or within other exoplanetary systems. And so no matter what you're interested in, you can play to your strengths and still make advancements in this fundamental question of whether or not we're alone in the universe. So that's what I would tell high schoolers, I think, is like pursue your interests in what interests you, and you can bring that to bear on this fundamental sort of human question of life in the universe.